Good evening, sir.
Yeah, good evening.
Sir, I might get problem in network issue today.
Yeah. So what are the problems that you'll be facing with the network?
Sir,
Yeah, what all problems will you be facing?
sir, I can't hear you properly at some times.
I'm saying, what are the network related problems that you may face? Like the network may cause lagging or somewhat.
Yes, sir, it's lagging. And
So what?
my system is also lagging, sir. That's it.
Okay. So today we'll continue with the physics class. All right. As we had started previously in the chapter gravitation, we had done Newton's laws of gravitation, universal law of gravitation. And with respect to the universal law of gravitation, we had done Newton's formula for the gravitation. So we'll do here universal law of gravitation is that what we do. Regarding the universal law of gravitation, what all we did, we had done that the force between any two masses is directly proportional to the product of masses and inversely proportional to the square of the distance between them. So we had learned about the universal gravitational constant. So we had done F equals to G m1 m2 over r squared. And on the basis of this, we had done a few questions also. So today we'll do a few NCRT questions and then we'll move ahead to the next topic, that is acceleration due to gravity. So first we'll do some NCRT questions. Okay. Let's see. So we had seen that it is the gravitational force of the sun which makes the earth revolve around it. Also, it is the gravitational force of the earth which makes the moon revolve around it. So everywhere it is the gravitational force which is attracting all the bodies. In the beginning, we had learned the definition of the gravitational force, according to which the gravitational force is the force of attraction between any two bodies, or the force which is always attractive in nature, that is the gravitational force. So the gravitational force acting on a body is F equals to G m1 m2 by r square. We had seen the value of G also. The value of G was given to be 6.67 times 10 to the power minus 11 Newton meter square per kilogram square. Right. So we'll just see the importance of the universal law of gravitation here. See, the universal law of gravitation, it successfully explains several phenomena which are believed to be unconnected. So what does it explain? It explains the force that binds us to the earth. Also, it explains the motion of the moon around the earth. So, the motion of the moon around the earth is explained by the universal law of gravity. It explains us that moon is moving around the earth because of the gravitational force. It is the gravitational force which is providing the necessary centripetal force. For the revolution, it requires some centripetal force, and that centripetal force is provided by the gravitational force. All right. So this is clear. Now, that another phenomena here, the fourth one, the tides, which we call as the low tides and high tides. So the tides due to the moon and the sun. The tides due to the moon and the sun, they are caused on the earth. So on earth, we observe after every 14 days a low tide and a high tide. So a low tide and a high tide, it is caused due to the motion of moon. So when the moon comes close to the earth, it attracts it pulls the water of the ocean towards it. As a result, the water of the ocean, it is in a continuous motion. So it causes some low tides and high tides because of the. Okay. Thank you very much. Next topic is free fall. So free fall means whenever an object is falling freely, so what is the force that is acting on it? We'll study the free fall now. So next topic is free fall. So a free fall, when an object is under the effect of, you know, दिया जरा. When an object is under the effect of gravity, it is said to be free fall. So, when an object is just falling freely means it is under the effect of gravity only. There is only one force which is acting on it, that is the gravitational force. Okay. So we call this situation as free fall. Right. So see what happens, how the object is going to free fall, and at that point we'll find out the acceleration in the body. Okay, so let's say here we have a body which is falling freely towards the surface of the earth. Let the mass of this object be m. So this object of mass m is being attracted towards the earth with a gravitational force. So we know the mass of the earth, let the mass of the earth be m, and the earth have a radius r. So as we can see here, this small mass m is attracted towards the earth. Okay. So which force is attracting it towards the earth? Yes. Which force is attracting it towards the earth?
The
Travel?
gravitational force.
Gravitational force. Okay. So the gravitational force is acting between which two bodies? The gravitational force is acting between which two bodies?
The M and R.
Between
M and R.
between this mass and the earth. Right? And suppose if we are throwing this to a certain height h, we threw this to a certain height h over here, such that this height which we have thrown is very, very small as compared with the radius of the earth. Okay. So that if increasing of a height by 1 meter, 2 meter, 3 meter, 10 meter, that's the height we are throwing. We are throwing it about 100 meter also. We are throwing it about 200 meter also. Still, it is nothing as in comparison to the radius of the earth. The radius of the earth is 6.4 times, or it is 6,400 kilometers. So you can write the radius of the earth to be 6,400 kilometers. Got it. So this is the radius of earth which we have. Now an increase in, or if an object is thrown to a height of 1 kilometer or 500 meters, so that does not make a much difference on the gravity. Okay. The value of the gravity does not change to a larger extent. So hence, for all the practical purposes, we will be taking this distance from the center of the earth up to the object to be equal to the radius of the earth only. Alright. So the gravitational force between these two can be calculated or can be given by the formula F equals G times m1 m2 over r squared. So the gravitational force between these two will be G m1 m2 over r square. If I put the values over here, I can obtain the gravitational force between them to be equal to G multiplied with m, the mass of earth, multiplied with small m, the mass of the object, and divided by r square, which is the radius of the earth. Does everyone agree with the formula that I have obtained for the gravitational force between them? Yes,
Yes, sir.
Jitendra?
Yes, sir.
Okay, is it okay to write the gravitational force between them to be equal to G m m over r squared?
Yes, sir.
Okay, so now we can see here Newton's third law of motion is applicable. What was the Newton's third law, Shravan?
Sir, every action has an equal and opposite reaction.
Yes, so every action has equal and opposite reaction. That means if we see here that the object is being attracted towards the earth with the gravitational force, so there should be an equal and opposite reaction being acted by the mass on the earth. Okay. So this gravitational force between them will always be Gmm over r squared. That means if the earth is attracting this mass towards itself, so this mass is attracted towards the earth like this. So the earth is also being attracted towards the mass. Also both the forces are equal and opposite. Both the forces are equal also. The force with which the earth is attracting that stone or that mass is the same force with which the mass is also attracting the earth. Okay. So it is always the force between the two masses will be Gm1 m2 over r squared, and hence the force between the earth's gravity and this mass is Gmm over r squared. Okay. So everything clear with this? Harshit?
Yes, sir, clear.
Okay. So if earth is attracting this mass with the force of Gmm over r squared, with what force is the mass attracting the earth? Yes. Harshit, can you answer?
Sir, I didn't understand.
Harshit?
Yes, sir, I didn't understand actually. Like,
Okay.
sir, I don't know how to solve.
So initially I told you that here for every action there is an equal and opposite reaction. All right. If I say that the earth is attracting the mass towards itself, so the mass is also attracting the earth towards itself. Both the masses, they are attracting each other with an equal amount of force. All right. So both the masses, they are attracting each other with an equal amount of force. So hence the force of attraction here will be the same. Earth is attracting it, if earth is attracting it towards itself with 10 Newton, so this mass is also attracting the earth towards itself with a 10 Newton. Now we want to find out what will be if there is a force acting on this small mass. So what will be the amount of acceleration? Okay, so this mass must accelerate towards the earth. Yes, the small mass m must accelerate towards the earth. All right. So this force can also be given by the formula which we have already used. We know that the force is equals to mass times acceleration. So if Gmm over r squared is the force that is acting between them, I can also obtain the amount of force to be equal to mass times acceleration, where acceleration will be there in this mass. All right. This mass will start accelerating towards the earth. All right. So every time the acceleration will be here towards the earth. We can write it as F equals to ma. Now if I equate both of them, so I get here Gmm over r squared equals to ma. Both the forces will be equal to each other. Either I obtain the force by the formula Gmm over r squared, or I obtain the formula by F equals to ma. Okay. So this mass and mass cancel with each other. I obtain the value of acceleration to be gm over r squared. Okay. I'm rewriting here. The gravitational force between the two masses is equal to gmm over r squared, equating it to equal to mass times acceleration, which we observe an acceleration in the mass m. So the mass and mass cancel from both the sides. You get the value of acceleration to be equal to gm over r squared. So this value of acceleration, it is independent of the mass. See, it is independent of the mass that you have thrown, and you can calculate this value. What this value physically means, this value means that here I have the earth, and suppose I take two objects here. I take a light object and still light object. So I drop these two light objects, a light object and a heavy object towards the earth. Okay, so I've dropped them. Which one of them will reach the earth surface earlier? The heavy object or the light object? Yes, Jitendra, which object will reach earlier? Jitendra?
Yes.
Jitendra?
Yes, sir.
Which object will fall earlier?
Yes, sir.
Hmm? Pranav? 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 Pranav?
Yes, sir. Sir.
Yes. So which one will fall earlier? See here, if you keep a heavy object, the acceleration that it will experience will be equal to gm over r squared. Here m is the mass of earth, r is the radius of earth, g is universal gravitational constant. Okay. So which object will have a more gravitational?
Object with more weight.
Yeah, the object which has more mass should fall earlier. But our calculation shows that acceleration in both the masses will be the same. Okay, so what our calculations tells us, it tells us whether you drop a heavy object or a light object, both the objects will fall to the earth at the same time. You'll have both the objects falling on the surface of the earth at the same time. They will take the same time to reach the surface of earth. All right. Okay, so if I can find out this value, the value of the acceleration would be, if I put the value of this g, which is the value of g is 6.67 multiply 10 to the power minus 11 multiply mass of the earth, which would be 6 multiply 10 to the power 23 divided by radius of the earth, which is 6,400 kilometers. So it can be written as 6.4 times 10 to the power 6, the whole square. So I will calculate this as 6.67 times 6 multiplied with 10 to the power 13 divided by 6.4 times 6.4. And here you will have 10 to the power 12. So just multiply them. If I multiply them, I'm getting 6.67 multiplied with 6. So this I'm getting 40.02 multiplied with 10 to the power 13 minus 12, which will just be 10, and divided by square of 6.4. So it's 6.4 multiplied 6.4, which is 40.96. So now if I divide this, I divide 40.02 by 40.96. This comes out to be 0.977 times 10, which can be written as 9.77 meter per second square. Okay. So Pranav, Jitendra, Shravan, Ashit, what did we calculate here? Yeah, what did we
Sir, the
calculate?
force of
The
gravitation.
force of gravitation.
No, we have not calculated the force of gravitation. We have calculated the acceleration that will be there in a mass which is dropped from a certain height. Okay,
Sir,
and the
it's
amount,
10 meter per second square, right?
it's 9.77 meter per second square, approximated to 9.8 meter per second square. So if you further approximate this, you will get this one to be equal to 9.8 meter per second square, approximated. Okay, a better approximation, not, I can't say the better approximation. You can say a value which everyone can utilize in the calculations will be 10. All right,
Okay, sir.
we can use here 10 meter per second square also. But this is the actual value which we are getting by obtaining or doing all the calculations. All right. So this is the amount of acceleration. Now see what it actually means. We have to understand this. There are a lot of questions based on this. It means that over here on the surface of the earth, suppose this be the surface of earth, and you drop a heavy object. So here you drop a heavy object, you draw a light object, you drop a still light object from the same height. So if you drop them from the same height, they will reach the ground at the same time. There will be same acceleration in all of them. So whether the ball be heavy or be light, you will get the same amount of acceleration. So here the acceleration would be, 9.8 meter per second square for all the objects which are falling freely under the gravity. all the objects which are falling freely under the effect of gravity, they will have an acceleration of 9.8 meter per second square. Got it? Yes?
Yes, sir.
Okay. So it also means that if you drop a hammer or a heavy ball, or if you drop a feather from here, if you drop just a feather from here, okay, so even the feather or the ball, they will both reach at the same time. If they are dropped from the same height, so they will reach the earth at the same time. Okay, so why don't we get this in reality? In reality, if you drop a feather and a heavy object, so the feather falls quite late, whereas the heavy object, it falls quickly. Yes. Yes. No answers. Jitendra, are you there?
So
Yes,
what's the
sir.
question?
Yeah. So why it doesn't? Why it's not possible on the earth? If you are dropping a feather and a heavy object, so we observe that the heavy object reaches first.
Because the mass is lighter of the leaf
So
and feather is lighter.
if the mass is greater, our calculation is saying that it will independent of the mass. See, here there is no factor as mass. The calculation which we have obtained, here there is no factor of mass. We obtained our acceleration due to gravity to be equal to gm over r squared. Is there anywhere mass?
No, sir.
No. Right? So there is no factor as mass. We should be observing all of this to be falling at the same time. Why we observe that feather falls late, whereas the masses fall earlier, heavier masses fall earlier. This is because of the air resistance. Since air opposes the objects, air opposes heavy objects less and light objects more. Alright. So there will be a lesser opposition to this. There will be a lesser opposition for heavy object, that means the ball which is dropped, and higher opposition to the feather which is there. As a result, the feather will take a longer time to fall, whereas the ball will take a shorter time. But if you perform this experiment in vacuum, if you perform this experiment in vacuum of dropping a feather and dropping a ball, both will reach the same time. Alright.
Yes, sir.
The same experiment, if you are performing in uh, vacuum, there is no air, so there will not be any opposition to their movement, and the feather and the heavy object, they will be falling at the same time. This is because the acceleration due to gravity is independent of the mass. Okay, so it is independent of the mass. There is no role of the mass over it. Got it? All right. So this acceleration due to gravity, it is denoted by the symbol G, a special name G, and it is called acceleration due to gravity. It is equal to 9.8 meter per second square. Right. Now, as I also told you that the Newton's third law of motion is applicable here. That means the force with which the mass is attracted, it is the same force with which the earth is also attracted. But we observe the mass to be moving towards the earth. Why don't we observe the earth to be moving towards the mass? Yes. Why don't we observe the mass to be moving towards the earth? The reason being, the acceleration produced in earth will be very small. The force is the same, but the acceleration of the earth is very small. Just see this, a small thing which I can show you. Okay, see, the acceleration due to gravity we have found out here as 9.8 meter per second square. Now we'll see the motion of objects under the influence of gravity or the force of the earth. So all the objects which are falling under the gravitational pull of the earth will have an acceleration of 9.8 meter per second. So this we will be using to find or to do the calculations on free fall. All right. So we'll see what are the calculations on free fall. So just tell me everyone, Jitendra,
Yes, sir.
Shravan, yes, yes. Is there any doubt from any topic which we have done? Any doubt on any topic
No,
that we have
sir.
done?
No, sir.
No. Okay. So first of all of you are clear that whether it be a heavy object or it be a light object, it should fall towards the earth with the same acceleration. All right, and it should take the same amount of time. So it should take the same amount of time, whether it be heavy object or light object. Okay, so we will be making small changes in our equations of motion which we have studied. So we have studied the equations of motion. Okay, just see one more thing I wanted to show. If it's possible, I'll show you here. Yeah, you see, just one thing. Yeah, this one is the video of, I think, a dropping of a feather and a ball. See the video of a dropping of feather and ball. So this experiment has been performed in vacuum or airtight container where there is no air. All the air has been removed from it. Okay, so you can see that when they are released at the same time, they drop off at the same time. They reach the surface at the same time. Right? So this experiment proves that acceleration due to gravity is acting same on all the objects. All right. So that means if you perform this experiment on the surface of moon, what will you observe? If I perform the same
There's no
experiment,
gravity in moon, so it'll float.
there is gravity, there is gravity, but there is no air.
Oh, okay, sir.
So there is no air on the moon. So on the moon, if a heavy object or a light object, they fall off, both will fall off with the same speed. Okay. So both the heavy object as well as the light object will fall with the same speed. Okay. So now we check our equations of motion. So we had seen the kinematic equations of motion as V equals to U plus AT. We have S equals to ut plus 1 by 2 at squared. And the third equation we have
V square
v
minus
squared
U square equals to 2AS.
2s. So whenever an object is
Sir
falling
equals
freely,
to.
yeah.
Sir, you wrote minus equals to.
Okay, so this is, so see, we have to make a little bit of change here. What change? That now our acceleration is fixed. Whether it be a heavy object or light object, it will have an acceleration equal to 9.8 meter per second. So this will be the amount of acceleration, 9.8 meter per second square. So at the place of A, we'll just replace it with G. So like V equals to U plus GT. So second equation will change like this. S will be equal to UT plus 1 over 2 GT squared. Then this one can be written as V squared minus U squared to be equal to 2GH. Here the displacement is the height. So the ball or the thing has been raised to a height, hence we replace it as H. Got it? So first equation has become V equals to U plus GT. Second equation has now become H equal to UT plus 1 by 2 GT square. And the third equation becomes V squared minus U squared equals to 2GH. Right? So now there will also be a change during the upward motion and during the downward motion. See what happens during the upward motion. So during an upward motion, what happens? Upward motion means we are throwing the ball to a certain height. So initially we have our ball and we throw it with a certain speed. So when we throw it upward with a certain speed u, so during this time the object is moving upward, but the acceleration due to gravity, is acting in the downward direction. So here you take the acceleration due to gravity in the downward direction. So we have to take here, since velocity and acceleration, they are opposite to each other. Are they opposite to each other? Yes?
Yes, sir.
Yes. So since they are opposite to each other, therefore, the acceleration due to gravity here will be equal to negative g. We will write it with negative sign. And hence, during the upward motion, the same equations of motion can be applied, just taking the acceleration due to gravity to be equal to negative g. So, I'll rewrite the equation for the upward motion as v equals to u minus gt. Okay. For the second one, we'll be writing h equals to ut minus 1 over 2 gt squared. So everywhere the g will become negative. The third one would become v squared minus u squared will be equal to negative 2gh. So since g is negative, so it will be a negative over here. So you don't need to remember all these formulas. Remember just the first formula, these three. Okay. Remember these three identities and use them accordingly. During the upward motion, you have to take the acceleration due to gravity as negative, and during the downward motion, the acceleration due to gravity has to be taken as negative. Sorry, positive. During the downward motion, the acceleration due to gravity is positive, and during the upward motion, the acceleration due to gravity is negative. Got it? We will see some questions now. So here, this question, let's see. Shravan,
Yes, sir.
okay, just go through this question. Everyone go through this question. An object is thrown vertically upward. So an object is thrown vertically upward and rises to a height of 10 meters. Calculate the velocity with which the object was thrown upward and the time taken by the object to reach the highest point. Okay, so have you read the question? Pranav,
Yes,
have you
sir.
read the question? Just read out the question again. Read out loudly. Yeah, Pranav, read the question loudly.
Yes. An object is thrown vertically upwards and rises to a height of 10 meters. Calculate the velocity with which the object was thrown upwards and the time taken by the object to reach the highest point.
Okay. So, which type of motion are they talking of? Are they talking of upward motion or downward motion?
Upward motion.
Yeah. So, this is the upward motion. We consider here the ball is moving upward. Okay. So, here we have the ball to be moving in the upward direction. The ball is moving in the upward direction. Whatever the class. So, you take a ball here. Okay. And this is an upward motion. All right. क्लास क्लास की बात करते थे. So during the upward motion, this is an upward motion. We'll consider the conditions for the upward motion. Okay. So during the upward motion, its initial velocity is given as is it given the initial velocity?
No, sir.
No. We have to find it out.
So you have to find the initial.
Yeah. What is given here?
Sir, distance, height.
Height. Okay. So the height is given to be 10 meters. All right. And what all we have to find? We have to find the initial velocity. We have to find the time taken. Now, when I am throwing it with a certain velocity in the upward direction, as it reaches to the top, what is the velocity at the highest point? When it reaches the highest point, what will be its velocity at this point?
So velocity will be 0.
Yeah, at the highest point, its velocity will be 0. So at this point, we will have its velocity to be equal to 0. Alright. So we can obtain this velocity to be equal to 0 at the highest point. Now, we will be using the third equation of motion. Okay. So for the third equation of motion, we have v squared minus u squared equals to 2as. Okay. So we know the value of v is 0. We write here 0. Minus u is, we do not know. This is what we have to find out. So we write u squared equals 2 times of acceleration. So what will be the acceleration? What will be the value of
9.8, sir.
9.8? A positive 9.8 or a negative 9.8?
Negative.
Negative or positive?
So negative.
Negative. Just we studied that during the upward motion, the acceleration due to gravity is negative. So here, acceleration A will be negative of 9.8. Okay. So this is negative 9.8. The displacement that it has gone is 10 meters. This is 10. For so I will obtain here u squared to be negative u squared equals to negative of, it will be negative of 196. Multiply 9.8 with 2, you are getting negative 9.6. You are getting 19.6. Then multiplied with 10, you get 196. Okay. So minus and minus cancel from each other. U, the initial velocity will be equal to square root of 196. I think the square root of 196 is 14. Yes, am I correct?
Yes, sir.
Alright. So initial velocity here is 14 meter per second. Alright. Try to do this question again at your home. Alright. Bye all of you. See you again in next class.